I did the problem F3-1. It has a block, a 550-pound block hanging from two tensions, two tension forces on opposite sides that go to a ring, and then there's a tension force going straight down. So the first step is to always draw the free body diagrams. So I drew one of the ring and I drew one of the block. The ring has a tension, labeled it TC, going up and to the right. It has a TB going up and to the left, and then it has a TD going down. So you want to label the tensions so that you can differentiate them from each other when you're solving. The second free body diagram was of the block, and all it has in this problem is weight going down and that same TD but going up in the positive Y direction. So your step 2, I broke it up into components. So I just drew TB force right here. I drew TB, and then you draw in the X direction and in the Y direction. That gives you TBY and TBX with the angle right here. So that helps me get my components. TBX is in the negative direction, negative X direction, because it's going to the left. Negative TB cosine 30. And then the Y component of B is going to be positive because it's positive going up, TB sine of 30. And you get the sine and cosine from the triangle that you draw. On the TC, I did the same thing. I drew TC exactly how it is on the free body diagram, and then I went down and I went right and up with it. So that gives me my TCX and TCY. And on this one, it doesn't give you an angle, but it gives you a reference triangle so that you can use that. And so on this, instead of using sine and cosine, you're going to use this. And so I put TCX equals TC times 4/5, because that's what cosine would usually be, would be this over that. And so that would make it 4/5. TC in the Y direction, it's going to be the same thing, except that's normally going to be this over, it's going to be TCY over TC. And so that would make it 3/5. So you have TC times 3/5 for your TCY component. The third step is to sum up all of the forces in each direction. And so you see here, I started sum of all forces in the X direction for my first free body diagram. So I did TCX minus TBX, and I get these signs from the direction. So TC in the X direction goes positive, TB in the X direction goes negative, equals 0. And then I plug that in for the values that I got. So I got TC of times 4/5, which is right there, minus TB cosine 30 equals 0. So that's my first equation. And then I sum up the forces in the Y direction. So I get TBY plus TCY minus TD. And you want to make sure you keep the signs correct from the arrow they're pointing to in the problem. So when you plug that in, it gives me TB sine 30 plus TC times 3/5 from up here. And then I went ahead and this is your, so negative TD, or minus TD, and TD, if you go over here, I get TD from my second free body diagram. So on the second free body diagram, it only has forces in the Y direction, and so I just have to sum up the forces in the Y direction, which is just TD minus the weight equals 0, which gives you TD equals 0, and we were given in the problem that the block is 550 pounds, so that's going to be the weight. So that gives me my TD, so I can plug that in here, and I went ahead and just moved that on the other side of the equal sign, so that gives me our second equation. And then the last step is to solve. So we're going to use the two equations because we have two unknown variables. So we're going to use the two equations to solve for these. So I just rewrote these right here just to kind of reorganize it. And then I started, since this one was a little bit simpler, it doesn't have the extra term on the other side of the equal sign, so I went ahead and just solved for TC. And so you just do algebra, just add this to this side and then either multiply it by 5/4, or you can divide the whole thing by 4/5, same thing. So that gives me TC equals 1.083 times TB. So you can use that to plug into your other equation for TB. I went ahead and rewrote the whole equation right here and plugged in TC right here. So here's the original equation. It was TB sine of 30 plus TC times 3/5. I went ahead and plugged that in, so it is 1.083 TB times 3/5 equals 550. Then I just simplified these terms, and it gives me 0.5 TB plus 0.6498 TB. So you can combine those and then divide the other side to get TB by itself, which gives you 478 pounds for TB. And then since you have that, you can just use this value and plug it back into here. And so what you'll do is you'll get TC equals 478 from this term times cosine of 30 times 5/4 from the original equation, and that gives you TC equals 518 pounds. So that gives you all of the tensions, which I forgot to mention is what the problem is asking for, is all of the tensions, forces in the ropes. So there you go.